what is the limit definition of the derivative really saying? Let's start by taking a step back to a topic you might have learned earlier in your math journey, rate of change of a straight line, also known as slope. We can find this by choosing 2 points and observing how much the y value changes for a particular change in x. For a straight line, the rate of change is constant, so no matter which 2 points we choose, their relationship stays the same. But what happens when we try to study change along a curve? Unlike with a straight line, the rate of change varies at different points. In other words, the slope is not constant and depends where you are on that curve. To explore how we might study change along curves, we can look at a circle. Keep in mind that circles are not technically functions on an xy plane. However, the fact that they are curved can help us understand a concept called the limit. Let's start by drawing a point on the circle. We want to figure out what the rate of change is at that point. The slope of the tangent line tells us that, but a tangent line only touches a circle at one point, and we need 2 points to find slope in the same way we did before. A clever solution to this problem is to start by looking at a secant line, which cuts through the circle at 2 points. Then we can observe its slope as the secant line approaches the tangent line. That way, even though the slope of the secant line is a pretty bad approximation of the rate of change at our initial point, it becomes more and more accurate as it approaches the tangent line. This idea of approaching is also known as the limit. Take a moment to let that sink in. Our goal was to find the rate of change at this point. Since the tangent line had only 1 point on the circle, and we wanted 2 to find its slope, we instead observed the slope of the secant line as it approached the tangent line. We can generalize this way of studying change to any curved function. If the point we are observing has coordinates x, f of x, then a second point on the graph, located h distance away horizontally, would have the coordinates x plus h, f of x plus h. The slope of the secant line that cuts through these 2 points would be f of x plus h minus f of x, the rise, over x plus h minus x, the run. And we can rewrite the denominator as just h. The phrase limit as h approaches 0, in this case, is just a way of saying that we are observing the scenario where the second point approaches the first point, and the secant line that cuts through them both approaches the tangent line to our initial point. This idea of using a limit to find rate of change at a point on a curve is one way of defining the derivative. Calculus is all about studying change, and the idea of the limit, I think, is a pretty clever and beautiful way of doing that. It lets us take something seemingly impossible, measuring change at a single point on a function, and makes it possible.